Let's do another Lewis structure example. This one slightly harder than the one we did last time, which was for HCN. But the same steps and rules are going to apply. So first off, just to go over the steps. 1, identify central atom. 2, draw skeleton. 3, count electrons. 4, determine number of bonds. In this case, using shared equals need minus available. Shared equals need minus available. And 5, fill in lone pairs. And as mentioned before in the last video, as you get better at these and as you deal with more difficult Lewis structures, shared equals need minus available won't be necessary or might not work for you, but until then we're going to keep using it. So first step, central atom. Okay, so the central atom is usually the one there is the least of in the compound provided. In this case we have CO2. C is the least, so that's going to be our central atom. Draw the skeleton, so C is central, so there's going to be an oxygen off of each side of the C. Alright. Next, count electrons. So carbon has 4 valence electrons, and there's 1 carbon, so that means there's 4 electrons from the carbon. Oxygen has 6 valence electrons. There are 2 oxygens here, so that's a total of 12 electrons. You add them up, 16 electrons. In terms of shared equals need minus available, the need is everybody here needs an octet. Octet, octet, octet. So our need is 8 for octet times 3, 24. So shared equals need minus available. Shared equals 24 minus 16, which is 8. So it's 8 electrons. And because each bond has 2 electrons, this equals 4 bonds. So then we need to draw in those bonds. We've already drawn a bond here and a bond here just to create the skeleton. So the next step is to add the 2 remaining bonds that we need. So you draw one here, and then you draw one here. And then the last step is fill in the lone pairs. So we need to make sure we've given all of the electrons available a home. So here we had 16 available. We've only given a home to 2, 4, 6, 8. So we still need to give a home to another 8. On top of that, the oxygen doesn't yet have an octet. Neither of these do. In order for the oxygen to get an octet, each one needs 4 more electrons, or 2 electron pairs. So I'm going to draw 2 electron pairs onto each oxygen. Now this works, because if you count them up, 2, 4, 6, 8, 10, 12, 14, 16, we've used up our 16 available electrons. Everyone has an octet. Great. Now you might ask, you might wonder, why couldn't I do my Lewis structure like this? And to be fair, that is a valid Lewis structure. But it's not the best Lewis structure available because, as we'll hopefully talk about later, you want to minimize formal charge on Lewis structures. In this case, this oxygen has a -1 formal charge, and this oxygen over here has a +1 formal charge, which is not as good as having no formal charge, because in this case the formal charges have to add up to 0. So this structure is valid, but it's not as good as this structure.